Okay, with K-DISC questions, we have to do the initial and final thing like we did last unit. So the initial concentration of CH3COOH is 0.1 molar. And then we know these are both 0 to start because we aren't given any information. So then it says the pH is 2.86. So by making that negative and going second function log, I can find the concentration of H3O plus to be 1.38 times 10 to the negative 3. And that will be the same for both H3O plus and CH3CO minus. Now we subtract that number to get our final concentration of CH3COOH, and it's 0.0986 molar. So we have to find percent dis. So part A, percent dis. So percent dis is your H3O plus, or it could be your OH minus, depending on the question, divided by the original concentration. So it is your H3O plus, or the amount dissociated, divided by original concentration. And then we times it by 100. So in this case, we're going to have 1.38 times 10 to the negative 3 divided by 0.100. And that gives us 1.38%. Now we have a rule to add in here, and it's called the 5% rule. And this is in your notes that I photocopied for you, but I'll write it down here too. If percent dis is less than or equal to 5%, then the concentration of the original acid or base is basically equal to the original concentration. So that means you don't have to use the subtracting value we saw on the previous slide. You can use your original concentration. And most of the time, that's what's going to happen. So now part B asks us to find Ka, and Ka is the same as Keq. You take your products over reactants, so we have H3O plus concentration times CH3COO minus concentration divided by the original concentration of the acid, because we know percent dis was less than 5. So we stick the numbers in, and we know CH3COO minus is the same because it's a 1-to-1 ratio. And we divide by the original concentration of 0.1, and you get a final answer of 1.9 times 10 to the negative 5. Now remember, just like Keq, Ka does not have any units. And that's how you do sample problem 1. Now moving on to type 2, we write out our equation, like always. Now remember, HX is just any acid, not a specific one. And we do our initial and our final. So when we start off with, we have a concentration of 0.9 of our acid, and then these are zeros. Now we're not given any information other than what Ka is, so we have to use X, just like we did in Unit 2. So this is X and this is X, and this is going to be 0.9 minus X, because we're minusing X to get that. And we added X here. So now that we have that information, we're going to learn about another rule called the opposite of the 5% rule. I didn't make these names up. This is what it's called. And what that says is if Ka or Kb or whatever we're calling it is smaller than 1 times 10 to the negative 3, then the concentration of the original acid in this case. We'll put substance because it won't always be an acid. Sometimes it'll be a base. Is unchanged. Sorry for the bad writing. So then that means we can calculate Ka, H3O plus times X minus, remember products go on the top, divided by HX. And we never put the water in the Ka, never. It's always just there to help dissociate. So I have 4.5 times 10 to the negative 4 from the question, that's Ka. This is X, and this is X, and I'm dividing by the original concentration of 0.9 because our Ka is smaller than 1 times 10 to the negative 3. Now this looks like a lovely mess of math, but basically to do the math, you just cross multiply like we've done all along. So X squared equals 4.5 times 10 to the negative 4 times 0.9. And we find out that it equals to 0.000405. And of course we have to square root that. And X is going to equal 0.0201 molar. Now that's your H3O plus. Now I believe the question asks us to find the pH. So to find the pH, we log it, in case you forgot over spring break. And your answer will be negative, but that's why we have the negative in the front to make it positive, and we get 1.7. Now the next part of the question asks us to find the percent dis. So percent dis is our amount disassociated, so our H3O plus, which was 0.0201, divided by the original concentration, which was 0.900, and we times that by 100, and you end up with 2.23%. When you're calculating percent dis, go at least to a couple decimal places. Now with type 2 with a twist, you don't have zero values for both. And how you can recognize this type of question is you'll be given two chemicals in the question. So in this question, we have HOCN plus water produces H3O plus and OCN minus. So our initial is 0.1 for concentration. This is 0, but OCN is going to be 0.05. Now this 0.05 came from the NaOCN in the question, and it's a 1-to-1 ratio, so that's why it's 0.05. So now we need to do the final, and this is going to be with x's again. So we're adding x here, we're adding x here, and we're subtracting x there. So we have 0.1 minus x, we have x, and we have 0.05 plus x. So this right here is the twist, because that's not what we normally have. Now, since Ka is smaller than 1 times 10 to the negative 3, we know we won't have to use this, and we won't have to use this when we figure out our equation. So now we're going to find the Ka, and Ka equals H3O plus times OCN minus over HOCN. So we have 3.47 times 10 to the negative 4 equals x times 0.05 divided by 0.1. So this was the original concentration, the 0.1. The 0.05 came from the concentration of NaOCN, which was added in with our acid. So again, you cross multiply. You're going to have 3.47 times 10 to the negative 4 equals 0.05 times x. Oops, I forgot to times by 0.1, so we'll put that up here. And we divide by 0.05, divide by 0.05. These cancel out, and x is going to equal 6.94 times 10 to the negative 4 molar. Now that's your H3O plus, because that's what we were trying to find. And then they wanted you to find the pH, so you take the log of it and you make it positive, and it's 3.15. So hopefully that helps you understand the notes a bit better, and text me or email me if you have any questions.